There we go. And then I'm going to share my screen on my iPad. Here it comes, hopefully. There it goes. Okay. So we're going to go through your Chapter 8 FRAPPY today and talk a little bit about confidence intervals. This FRAPPY was kind of a unique one because you actually didn't have to do a whole lot of work for this one. This one was more about just interpreting what was already done for you. And what does it mean? What does this confidence interval mean? And what does that do for us? And how do we make decisions based on the confidence interval? So that's kind of what this FRAPPY was about. So I will go through the question, then I will go through the model solution, and then we'll talk about the rubric and how it would be scored. If you haven't had a chance to look at the question yet, here is your chance. So it says, members at a popular fitness club currently pay $40 per month for a membership fee. The owner of the club wants to raise the fee to $50, but is concerned that some members will leave the gym if the fee increases. To investigate, the owner plans to survey a random sample of the club members and construct a 95% confidence interval for the proportion of all members who would quit if the fee was raised to $50. Okay. So part A says, explain the meaning of 95% confidence in the context of this study. So explain the meaning of what being 95% confidence is. Okay. Part B says, after the owner conducted the survey, he calculates the confidence interval to be 0.18 plus or minus 0.075. Interpret this interval. So then you actually get an interval that you need to interpret. Part C says, according to the club's accountant, the fee increases will be worthwhile if fewer than 20% of the members quit. According to the interval from Part B, can the owner be confident that the fee increase will be worthwhile? And explain. And then the last one is, one of the conditions for calculating the confidence interval in Part B is the n times p, the large counts condition. N times p being greater than or equal to 10, and n times 1 minus p hat being greater than or equal to 10. Explain why it's necessary to check this condition. Okay. So that's the question. Again, you didn't have to do a whole lot of you didn't really have to do any calculations for this question. This was a lot of interpreting and explaining. So take that for what it's worth. This would be, I think, a good question on the AP exam for you. Most people would be able to answer this. Okay. So the first part A, was explain what being 95% confidence means. Explain the meaning of 95% confidence in the context of the study. So what they say is, and remember, this is the model solution. That doesn't mean it's the only way to write it. This is just the model, okay? If many samples of members were selected and many 95% confidence intervals were constructed, about 95% of the intervals would capture the true proportion of all members who would quit. So many samples of members and many 95% confidence intervals. Done. This goes back to the difference between confidence interval and confidence level. So there's a confidence interval that you can construct based on one sample. You can take a sample, construct the confidence interval. If you do that over and over and over and over again, then you get to a confidence level. You get a 95% confidence level, saying that 95% of your intervals captured the true proportion. So that's what they mean about being 95% confident in your level. Okay. So the key things to get at there are the many samples and constructing many 95% confidence intervals. If you didn't have the two words many, talking about doing this over, you have to allude to the fact that you're going to repeat the process. That's what they want there. And then also put the context in. True proportion of all members who would quit. Okay. So B gets into one confidence interval. It says after the owner conducted the survey, he calculated the confidence interval to be 0.18 plus or minus 0.075. Interpret this interval in the context of the study. So this is the only time that you really do any sort of math of any kind. And it's very simple math because all you need to do is take that 0.18 and add the 0.075 and subtract. You know, it was 0.18 plus or minus 0.075. So you do both 0.18 plus 0.075 and then 0.18 minus 0.075. Okay, that's where they get this. So they always respond to these interpretations with a we, even though there's only one person answering. It seems weird, but you say, we are 95% confident. Because usually there's more people involved in the process. That's why there's a we there. But I've never not seen it answered with a we. Okay, so don't let that throw you off. We are 95% confident that the interval from 0.105 to 0.255 captures the true proportion of all members who would quit if the fees were increased. Done. Okay. State your confidence level. State what the interval actually is. State what you're measuring, because we're not there yet, but you will do confidence intervals for means. So you have to state that it's true proportion, not a mean, and then put it in the context. Members who would quit if the fee was increased. Okay. Part C. Part C asked, according to the interval from Part B, can the owner be confident that the fee increase would be worthwhile? Here's where you have to actually pay attention to the interval. So now you've got this interval that you found in Part B, and your answer to this one is no. You're not confident. The accountant told you that you should have less than 20% who quit the gym in order for it to be worthwhile. But your interval includes values that are above 0.2, or in other words, 20%. So since there are plausible values in the interval that are above 0.2, the owner cannot be confident that the true proportion is less than 0.2, which means the increase may not be worth it. Okay. Then in Part D, now it talks about the 10% condition. And the large counts condition. And this, we really get into a definition here. The biggest thing about Part D is, can you define what that condition is for? So it says we check this condition to make sure that P hat has approximately normal distribution. This allows us to use the standard normal distribution to find the critical value that we need for that interval. If we don't show that we have the large counts condition, then we cannot state that our distribution is approximately normal. If you can't state that your distribution is approximately normal, then you cannot use normal calculations. Okay. And again, this really just gets into a definition. That's all that's being looked at in Part D. You didn't even have to actually do the calculations. They just kind of want you to say, why is this important? Okay. All right. So that's the model solution. Now let's go into scoring. So now I'm going to scroll down, not on my computer, I'm on my iPad. See, 2 devices. I just get lost at where I actually am. Okay, so let's go back and score. So Part A, remember Part A was the one where you had to say many, many samples, many 95% confidence intervals, capturing the true proportion. Here's what they're looking for. It says essentially correct if the response provides a correct interpretation of the confidence level in the context of the study. Correct interpretation can take one of 2 approaches. So the first approach is based on the concept of repeated sampling. The response must include the following 3 components. Mentions repeated sampling. They also put some other verbiage in there. You could say in the long run, or using this method over and over. Mentions 95% of the intervals will capture the population proportion, and then includes the context. So say that you're going to do it many times. Say that 95% of them will capture the true proportion. Talk about what it's about of members who will quit the gym. Okay. Here's the other approach. That's usually how I write it, by the way. This method 1, that's typically where my brain goes. But here's method 2 that they say is also appropriate. Based on probability, the response must state that there is a 95% probability that a random sample selected in the future will produce an interval that captures the actual value of the population proportion of members who won't quit. So the second method talks about it in terms of probability more than in terms of the actual confidence interval and repeating that. My brain thinks about confidence intervals and confidence levels this way. Confidence interval is when I take one sample and construct an interval on that sample. Confidence level is when I do that over and over and over. If I keep taking a sample and doing an interval, keep taking a sample, doing an interval, keep taking a sample, doing an interval, that leads me to a confidence level. So that's why my brain thinks of it as method 1. Because to me, that's how I associate those 2. Confidence interval is for one sample. Confidence level is when you repeat that process many times. Hopefully that makes sense. Method 2 is perfectly fine. For whatever reason, I just don't think of it that way. There you have it. Okay. They say your P, it says partially correct if a student provides an interpretation of the confidence level that includes 2 of the 3 components required for the repeated sampling interpretation. And then or provides a correct probability interpretation but doesn't give the context. Okay. So basically, if you did 2 of the bullet points but not the 3rd, you'd get a P. Incorrect is if you attempt to interpret a particular confidence interval. Here's where you have to be careful. If you start interpreting a confidence interval and not the confidence level, then you've missed the mark. Okay. Or if you provide an interpretation of the confidence level that mentions at most one of the 3 components. So if you only said one of the bullet points, but not the other 2, they would call that incomplete. They wouldn't give you a P for that. Okay, so confidence interval versus confidence level. They're 2 different things. Okay, let's look at B. So B, was where you had to actually construct the interval. They gave you the p hat value and they gave you the z star times the standard deviation piece on the other side, and you just had to do the plus and minus. And then you had to interpret the interval. So now you are interpreting an interval in B. So in B, it says you're essentially correct if the response gives a reasonable interpretation of the interval that includes the following three components. Inference about a population proportion, stating that you are 95% confident, and then putting it in terms of context. The inference about a population proportion is where you say the interval. We are 95% confident, that's actually the second point, that the interval blah, blah, blah captures the true proportion. That's the inference. And then of members who would quit the gym if the fee increases, that's the context. Okay. Partially correct if you give a reasonable interpretation of the interval that includes two of the three, and then incorrect if it does not meet a criteria. So if you only did one of the three things, or you did none of them, or your values were wrong, then you'd get an I. Okay. Let's look at C. Okay. C, in C we were, oh yeah, this was the one where like we have to actually make decisions here. There's a reason we construct these confidence intervals so that we can make an informed decision before we make an entire program change for our, in this case, gym. So the accountant says that the fee increase is worthwhile if fewer than 20% of the members quit. That's an important piece of information. And then according to the interval, can the owner be confident? Make sure that you actually answer the question. That happens a lot. So can the owner be confident? First and foremost, you had to say no. And they are going to look for the word no or the implication of no. And then you had to say why. So essentially correct if the response correctly state that because the values greater than or equal to 0.2 are computed in the interval, the owner cannot be confident that fewer than 20% of the members will quit. Okay, so you had to say no, and you had to say because there are plausible values above 0.2. Okay, partially correct if the response indicates that the goal is to check whether the values above 0.2 are in the interval, but make errors on the implementation. So examples of errors include the following. The response notes that 0.2 is within the interval, but does not draw a correct conclusion. So if you say something along the lines that 0.2 is in the interval, but other values are in the interval, so we don't know it's exactly 0.2, maybe something like that. Or if you draw attention to the other side of it, some people get confused at what side they're looking at. And they say, you might say, oh, because there's values less than 0.2. Well, that's what we're looking for. So make sure you're referencing the correct side of the interval. Okay. Another error that they say is common is response makes an arithmetic error in computing the endpoints of the interval. So just be careful when doing your math. You're going to have a calculator. You can type your decimals into your calculator. But if the conclusion is consistent with the computed interval, then they'll give you a P. So that's good. Everything else is an I. Okay. Last one. Last part. This is where we get into a definition. We're really just talking about what does it mean to find that condition and why. So in part D, it says this was where the question said, explain why it's necessary to find n times p hat greater than or equal to 10 and n times 1 minus p hat greater than or equal to 10. Okay, and then the answer was those two things have to be true in order for us to use normal calculations. So they say that it's E, essentially correct, if the response says that the condition is necessary for both of the following reasons. The first reason is so that sampling distribution of the sample proportion is approximately normal. And then once we know it's approximately normal, we can use normal distribution to calculate the critical value Z star. If you're using a Z-score, in this case, that's what a critical value is. A critical value comes from a Z. If you're using a Z-score, then you better know that your population is normal. You can't use that Z star critical value unless you have determined the population is normal. Okay. If you did not mention the critical value, because that's a common thing. If you just said, so we can use normal distribution, but you didn't mention the critical value, I think you'd be here. I think you would get a P, which is kind of a bummer. You have to state that it's normal. You have to state that you can use normal calculations so that you can find the Z star. Okay. And then if you didn't do any of that, incorrect. Okay. There's a little note here. It says the first reason must be about the normality of the sampling distribution p hat. Responses that make statements about the population and or sample being approximately normal cannot earn credit for the first reason. What they're saying here is it's not enough for us to just say that the population is normal. We have to say that the sample proportion is normal. Okay. So if you're talking about the population being normal, or if you're talking about the one individual sample being normal, that's not what's happening here. What's happening here is that the sampling proportion, or they call it sampling distribution, either one of those phrases would be fine. Sampling proportion or sampling distribution must be normal. We don't actually know the shape of the population. We weren't told. We don't know what it would look like. We don't even know the shape of the one sample that he took. We don't know. But if you do the large counts condition, you can say that the sampling distribution is normal. Okay. All right. Not a lot of calculations in this one. Really just a lot of explaining and defining. For some of you, that may be good. For some of you, that may be not so good. A through D, which means each part had a point. Your E is a point, your P is a half a point, and your I is no points. If you're between like a 2 and a 3 or a 3 and a 4, or even a 1 and a 2, you can decide, was I closer or was I further away? And then you go up or down from there. That's how you score it. Okay. Does anybody want to ask any questions about this one? I know it's our favorite thing to talk in a Google Meet. Okay, I'm going to stop recording.